Hello students, welcome to Physical Science Digital Classes Mahabubabad. Myself Narendra Babu Kotla, PGD Chemistry, TSMS Mahabubabad. Human Eye and Colorful World. Class 10, Part 4. In this session, we are going to discuss about defects of vision, myopia. In our previous class, we discussed about accommodation of focal length. So the maximum focal length of eye lens is 2.5 centimeters and the minimum focal length of eye lens is 2.27 centimeters. Now, I have a question. What happens if the eye lens is not able to adjust its focal length? One more question. What happens if the focal length of eye lens is beyond the range of 2.5 centimeters to 2.27 centimeters? My question is, what happens if the eye lens is not able to adjust its focal length? Why? Because eye lens can be able to adjust its focal length, so that is between 2.5 centimeters to 2.27 centimeters. What happens if the focal length of eye lens is beyond the range of 2.5 centimeters to 2.27 centimeters? Let us find out. Sometimes the eye may gradually lose its ability for accommodation. Sometimes the eye may gradually lose its accommodation. In such cases, the vision of a person becomes blurred and he cannot see either the distant objects or nearby objects clearly and comfortably. The person is said to have a defect of vision. And the defects of vision are also known as defects of eye. Sometimes the eye may gradually lose its ability for accommodation. In such cases, the vision of a person becomes blurred and cannot see either the distant objects or nearby objects clearly and comfortably. Person is said to have a defect of vision. The defect of vision are also known as defects of eye. There are three common defects of vision. These are myopia, hypermetropia, presbyopia. First one, myopia. Myopia is also called as short-sightedness or nearsightedness. Myopia is the defect of vision due to which a person cannot see the distant objects clearly. So that means he can see the nearby objects clearly. Myopia means it is also called as short-sightedness. Myopia means so the defect of vision due to which a person cannot see the distant objects clearly. Means the person can see the nearby objects, but the person cannot see the objects which are far away from him. So the defect in which people cannot see objects beyond far point is called myopia. Actually, for a healthy person, the far point is for a healthy person is infinity. Means a healthy person can be able to see the objects which are present at far point. Means objects are at infinity. But myopia in the sense, the defect in which the people cannot see objects beyond far point is called myopia. For example, a child having the defect called myopia and sitting on back benches in the class, and that child cannot read the writing on the blackboard clearly, though he can read his book comfortably. So that means a child who is suffering with myopia, if he is sitting on back benches, he cannot read the content which is present or which we are writing on the blackboard. But the person can be able to read the textbook clearly, and the student or child can be able to read his notebook clearly. But the person cannot read the content which is present on the blackboard. So this is myopia. That means this child cannot be able to read the content which is far away from him. But the child can be able to read the content which is present in the book. That means he can be able to read the content in the book is with him. That means the content which is very near to his eyes. that is myopia. Once again, myopia in the sense the defect of vision, so due to which a person cannot see the distant objects clearly. This is myopia. The far point of an eye suffering from myopia is less than infinity. The far point of an eye suffering from myopia is less than infinity. Such a person can see clearly only up to a distance of a few meters. So, a person who is suffering from myopia, for him, actually the far point is less than infinity. Just now we discussed for a healthy person, the far point is infinity. He can able to see the objects far distance. But the person who is suffering with myopia, the far point is less than the infinity. That means he can able to see clearly up to a certain distance, but he cannot see the objects which are far away from him. For these people, the maximum focal length is less than 2.5 centimeters. For such type of the people, the maximum focal length is less than 2.5 centimeters. In such cases, the rays coming from the distant objects after refraction through eye lens forms image before retina. In such cases, in the sense the person whose far point is less than infinity, in such cases the rays which are coming from the distant objects after refraction through eye lens, they forms image before retina. Let us see this. So if you observe this image, the rays are coming from far distance, and these rays are coming from the infinity distance. These rays incident on eye lens and refracts and forms the image before the retina. Actually, if a healthy person, if the light rays are coming like this from far distance, so the eye lens can able to adjust this focal length up to 2.5 centimeters. That's why the image will form on retina. But here in this case, the person suffering with myopia, so the light rays which are coming from far distance after refraction, so the light rays, they forms the image before the retina. If you observe this, the image that forms before the retina. Okay? And one more image, let us see. If you observe in this is the far point M. M, we are representing it with the far point. So the rays which are coming beyond the far point, or which are coming beyond from the far point, and these light rays after refraction, so they forms the image before retina. A healthy person can see objects at all distances more than 25 centimeters clearly. But a person with myopia can see objects clearly up to a certain distance. A healthy person can see objects at all distances more than 25 centimeters clearly. But a person with myopia can see objects clearly up to a certain distance. Let the extreme point from where an object appears clearly to a person with myopia be far point M. Let us consider here extreme point from where an object appears clearly to a person who is suffering from myopia, and that far point we can consider it as M. So actually far point in the sense that is the infinity for a healthy person. But the person who is suffering with myopia, for him the far point means the extreme point from where an object appears clearly. So that is far point, and that far point we can represent it with M. If the object is at M or in between M in the sense far point to the myopic person. If the object is at M or in between M and point of least distance of distinct vision L, the eye lens can form the image on retina. So M in the sense the person, so the extreme point from where an object appears clearly to a myopic person. So that's why he can able to see the object clearly. Okay, if you observe in this is the M. So actually the person suffering with myopia, he cannot able to see the object beyond this far point. Okay, for a healthy person, far point in the sense that is infinity. But for person who is suffering with myopia, the far point is here M. So beyond this, he cannot able to see the object. He can able to see the objects between, if the object is placed at M or between M and the least distance of distinct vision. These two. If you place the object at M or if you place the object between these two, he can able to see the object clearly. See here in this case, the object which is present between M and L. M in the sense far point and L in the sense least distance of distinct vision. The eye lens can form the image on retina in both these cases. So, eye lens can form clear image on retina when an object is placed between far point and point of least distance of clear vision. Eye lens can form clear image on retina when an object is placed between far point and point of least distance of clear vision or distinct vision. Myopia is corrected by using spectacles containing concave lenses. Myopia is corrected by using spectacles containing concave lenses. When a concave lens of suitable power is placed in front of the myopic eye, then the parallel rays of light coming from distant object are first diverged by the concave lens. What happens here? So this myopia is corrected by using spectacles containing the concave lens. When a concave lens of suitable power is placed in front of the myopic eye, then the parallel rays of light coming from the distant object, so the parallel rays which are coming from the distant object are first diverged by the concave lens. Parallel rays are coming from the distant object in the sense beyond the far point. If the light rays which are coming from the object which is beyond the far point, and those light rays first diverged by the concave lens instead of the eye lens first, so these light rays are diverged by the concave lens. So due to this, the concave lens forms a virtual image of the distant object. So this concave lens diverges the light rays which are coming from the beyond the M, beyond the far point. Okay, and due to this it forms the virtual image of the distant object at the far point M of this myopic eye. Since the rays of light now appear to be coming from the eye's far point M, they can be easily focused by the eye lens to form an image on retina. If you observe this diagram, so this is the concave lens, this is the concave lens. The parallel rays which are coming from infinity distance beyond the far point, and these light rays first diverged by the concave lens. So these diverged light rays, it forms the virtual image at far point M. Okay, it forms the image at far point M, and that image is virtual image. Now this image that acts as object to the eye lens, the image which is formed at a far point, that acts as object to this eye lens. Due to this, so the eye lens that forms image on retina. It forms image on retina. Note, the concave lens used for correcting myopia should be of such a focal length that it produces a virtual image of the distant object at the far point of the myopic eye. The concave lens used for correcting myopia should be of such a focal length. That means the concave lens should contain the focal length or power. It should produce a virtual image of the distant object at far point of the myopic eye. Lens formula can be used to calculate the focal length and hence the power of the myopia correcting the lens. In this case, the object distance u is infinity and image distance is equal to distance of far point. So if you want to find out the focal length of the concave lens, so which lens we have to use for correcting the myopia? In this case, the object distance is infinity and the image distance is to distance of the far point. Let us see this. So u is minus infinity and v is minus d. Minus d in the sense this is equal to the distance of the far point. U is the object distance. That means the light rays are coming from the infinity distance. That's why we are taking it as infinity. And V is the image. Where the image is forming at the far point. That's why V is equal to minus capital D. Let F be the focal length of biconcave lens. Using lens formula, 1 by F is equal to 1 by V minus 1 by U. So then 1 by F is equal to 1 by minus D. Why? Because 1 by infinity will becomes 0. So that's why the focal length of that concave lens will be minus D. Here F is negative, that showing that concave lens. Thank you. Thank you for watching this video.